Okay, today we are continuing with reviewing some of the items that you've learned before. So no new stuff, at least right now. Still doing the reviews. Okay, the topic we're looking at first is polynomials in general, but let's start with something that you have worked with before, polynomials in one variable. A polynomial is an algebraic expression, and since we're dealing with one variable, then all the terms will be of the form ax to the n, where the a is a real number. It doesn't matter if you have that subscript that I've put on a sub n. A sub n is a member of the real number system. While when we look at the variable, in this case I've called it our favorite letter x, the power that we have is this whole number, and remember that your whole numbers are starting from 0, 1, 2, 3. Now there are some special names given to, if we're just looking at terms of this form. So if I start out, if I have ax to the n, right, so although we have the word power, etc., to describe the n, we can also, when we're talking about the term, this n will also be called the degree of the term. So not just the power, but the degree of the term in this case, right? And if since we're dealing with a being a real number, we will say that this is a numerical coefficient of x to the n. All right, so that's a proper way of saying them in the context of a polynomial. All right, so again, let's look at some examples. Here are when we have a single term, it is called a monomial, and you've dealt with some of them in the previous lesson with exponents, etc. We multiplied two monomials and ended up with another monomial. So a monomial is a single term of this form that we are looking at. Now if let's look at one example. Here, if I start out with root 7x, then what I'm saying is that the coefficient, the numerical coefficient, was root 7. The square root of 7. Root 7 is a nice real number, or nice enough. It's just not a whole number. Right, and the variable, of course, we're dealing with x, and the degree of this term would be 1, right? Because we all remember that x is the same as x to the first power. All right, let's look at another example. If I had 3, 4, x to the 8th, again, we can talk about the numerical coefficient, and what is that? No, it's not 3, it is the full number, which is 3/4. 3/4 of x to the 8th, 3/4 x8, right? The degree is 8, right? Do recall that there are several ways that I could write this, equivalent forms. I could have written 3x to the 8 over 4. Yeah, I think that's right. And 3x to the 8th, let's see. Yeah, I think we have them. So 3 over 4, and here you can see the full coefficient of x, and yeah. So, and even if I should have written this as, say, 3x to the 8th over 4, it would be up to you to recognize that the coefficient, this is just x to the, 3x to the 8th over 4. So recognize the coefficient, the numerical, the numbers in front of the variable. So you are pulling that out and looking at your fractions, right? A times c over b is the same as a over b times c over 1, or a over b times c. Just an aside there, so that you can remember how to pick out the coefficients. All right, one more, and if we in identifying a single term, so here we go. If I should give you the number 5, well, this is we don't call it a coefficient. However, we'll talk about the degree. The degree here is 0, and when the degree is 0, it is called a constant term. Why is the degree of this 0? Two different ways to explain it. We can say the absence of any variable, but equally we could say that this is really 5x to the 0. Recall that x to the 0 is 1, right? So in essence, when we go back and we are defining a term or a polynomial term, a monomial, we could also say that it is of the form ax to the n, or it could be a constant, as we have seen now in example 3. All right, let's look at some items that are not monomials. So if it's not a monomial, it is not of the form ax to the n, where n is a nice whole number, or the degree is not a whole number. So, oops, sorry. Let me just, so not a monomial. If I had, say, 2 square root of x, recall that this is the same as x to the 1/2 power. The fact that we have a power that's not a whole number, then it means that this is not a monomial, right? Okay. Other examples, if I should look at clearly something with a negative power, again, that would not be a monomial because of that power. Okay. Power is negative. And if it's not so obvious, and this is why we went over exponents first, if I had, say, the expression 5 over x, recall that this is the same as 5x to the minus 1. So in either form, I should not have a variable in a denominator when I'm describing a polynomial or a monomial, and I should not have a negative power. All right? Any questions? So these were not monomials. All right. Now, of course, all of math, we don't just have single terms, we put them together. And so let's talk about that. So in general, terms are joined by an addition sign. What do I mean? I want you to be clear about what a term is. So if I gave you a plus b, it means that the terms are a and b. On the other hand, if I gave you c minus d, do remember that c minus d is the same as c plus negative d. So in this case, the terms are c and negative d. So in essence, when we look at this this abstraction here, then what we can do is we can say all terms travel with their signs in front. It's almost as if they had a first name and a last name. This is positive c, so it showed up here as positive. This is a minus d, so minus d is the same as adding negative d. Here's the sign which comes over there. All right, some terminology that again I'm sure you're familiar with. If I join two terms together, two monomials, we form a binomial, right? If I have a trinomial, then this would be three monomials. Okay. But in general, we just reserve the term polynomial for 4 and above, right? When we're joining them together. The entire class is a set of polynomials, whether it is a single term or many. Alright, so let's again see if you've gotten the gist of what I've talked about. So if I gave you a couple expressions and I said list the terms. So if I start off with, say, number 1, 2x plus 3. What are the terms? Correct. 2x and 3. There's no need for me to write plus 3 or so on. And notice the comma in between. I'm listing the terms. Alright, let's look at another one. 5x squared minus 7x minus 8. Alright, by the way, this was a binomial. I had two terms. And again, here, this is called a constant. The 3 is called a constant term, while the 2 on this would be the numerical coefficient of the variable x. Alright. Okay, let's look at the next expression here. It's 3 terms, so it will be a trinomial, or is a trinomial. All the powers on the variables are whole number powers. The absence of one of a variable on the last term just mean that is a constant term, but it's still acceptable. It's still a monomial in its right. Okay, so what are the terms here? We would have positive 5x squared, no need to write the plus sign, but because of the signs here, negative 7x and negative 8. If you did not put the negative signs, you would not get the points, right? So if we go back to this, no problem. As we mentioned, that all terms are joined by a plus sign. So if you look at my writing or presentation here, then you will see clearly why I picked out the positive or negative, respective positive or negative signs for the different terms. If we were speaking about some of these things, again, minus 8 would be the constant term. But over here, the 5 is the coefficient of x squared, or numerical coefficient of x squared, while the minus 7 is the numerical coefficient of x. Alright, now I know that these are topics that you have done before, but as we go on further in this class, the expectation is that you will actually know the names of everything that you are doing or using. Previously, you probably focused more on getting the algorithms, the methodology of solving something, and did not pay much attention to what the names and terminologies were. But this time you will have to, because as we go on, we're not just going to give you drills and say, hey, solve this or factor or simplify. You will actually be given a statement which says that the numerical coefficient of the squared term is 7, and you will have to be able to write, okay, 7x squared if my variable is x. Alright, So moving on, let's get a few more definitions, because that seems like the appropriate thing to do as I'm warning you now. So the definitions. We will talk about the degree. We've talked about the degree of various terms. We'll talk about now the degree of a polynomial. And that degree of the polynomial is equal to the degree of the highest degree term. Right? So if we go back up here, let's do this in a different color. The degree of each term. Right? Degree. Oops, a little bit. Okay, so let's go again. Degree of the term. Degree of this term is 2. The degree of this term is 1. X to the first power. There's no x present, so the degree is 0. The degree of the polynomial 5x squared minus 7x minus 8 will be 2. The highest degree of the degree of the highest degree term. All right. Likewise, in the earlier one, the degree of 2x plus 3 would just be 1. The degree on the 2x is 1. The degree on the constant is 0. And so we have the overall degree of the polynomial, that is the entire expression, is 1. All right. I've been very nice to you so far in that I have written these polynomials in order. That is, I started with the order highest power term, then I decreased. This will be known as the descending order of writing a polynomial in descending order. And let's discuss that. There are two orders, the ascending and descending order. So the descending order, as you can guess, is writing a polynomial. So write the polynomial from highest degree term, highest to lowest degree, right, terms. And of course, if I said ascending order, then we would write the polynomial from lowest. It would go the opposite way to highest degree term. All right. So in general, we might not even order them when we give them to you. So for example, let's look at this one. If I said 5x squared plus 7x cubed minus 8. Number one, let's even start out. We can talk about the degree of each term. So we can say the term degree. The term degree, this would be 2, 3, and 0. So it's definitely not ordered. If I am writing this in the ascending order, then I start from the lowest to the highest. So it becomes minus 8 plus 5x squared plus 7x cubed. And if I now decided to write this in descending order, it's just in the opposite way to the ascending. Either I could look at that and reverse my setting, or go back to the original and find the highest degree term, which was 7x cubed, 5x squared next, and then minus 8. All right. Now, in most times, the preferred order, or the order that we use most items, particularly at this stage, will be in the descended order. All right. Now, irrespective of the order, we are going to be talking about something called the leading term of the polynomial. So the leading term of a polynomial, and this is the highest degree term. Now, in our case here, this highest degree term is 7x cubed. So I would find it at the end in my ascending order, or at the very beginning when I'm doing my descending order. Again, just remember, leading term goes with the highest degree term. There's something called the leading coefficient of the polynomial. So the leading coefficient of a polynomial is just the coefficient of this term. It's the coefficient, or numerical coefficient, of the leading term. Oops. Right, so again, in both cases, my numerical coefficient would be 7. I am looking at my highest degree term, that leading term, and just the numerical value before it. Okay? Alright, so not very challenging there. Let's maybe I should put up a couple expressions, and let's see if you understand the various terminology as you fill in the blanks. All right, so give me a couple of seconds and I'll put something up. All right, let's look at these first 5 questions. What we have here are expressions, and which I've labeled 1 to 5. I want you to give me the terms that make up these expressions. Then you decide, is it a polynomial or not, y or n. The degree, if it is a polynomial, then you'll answer the rest. That is, give me the degree of the polynomial, the leading term, and the leading coefficient. All right? Okay, so let's fill these in. So as we go through, there are only 2 terms in the first, so it makes it a binomial. Yes, they're of the correct form. The first term is x to the 10th and -1/5. Is it a polynomial? Yes, it follows the right form. The degree of this polynomial is 10. The leading term is just x to the 10th. The leading coefficient is +1. So it's not shown here, but understood that this is a 1. All right. If we look at the next number 2, it is not in order. You don't really need to, but if you could, if you wanted to put them in order, I'll put them in order as I write the terms. So the terms are -2y to the 5th, that's the highest term, or highest degree term. Then I'd have +y to the 4th. Next I would have -3y cubed. Next I have y squared. And then finally 7. So I have 5 terms in my polynomial. They're of the right form, that is nice whole number powers, and the overall degree is 5. The leading term is -2y to the 5th, and the leading coefficient, the numerical coefficient, is -2. All right, There's only a single term for number 3, which is 0. Is it a polynomial? Yes, it's a polynomial. It's a constant term. Recall that this is a constant term. Right? The degree of a polynomial is 0. Leading term, well, that's just 0. It's a constant. We don't really apply these words when we are talking about just a constant. Alright, next on number 4, the terms again. 3x squared minus 6 root x and 5. However, this is not a polynomial. It is not a polynomial because that second term, negative 6 root x, is really negative 6 x to the 1/2 power. We can't have fractional powers, right? So the other items would not be applicable because they're dealing with a polynomial. All right. How about, I see a square root also in number 5. Does that already mean that it is not a polynomial? So again, let's look at the terms. The terms are 2x to the 4th, root 8x, and 3/8. This is a polynomial. The root 8, this is a root 8, that's just some number, right, times x. You may remember that root 8 is an irrational number, and if we did an approximation to say 2 decimal places, it would just be telling me that this is say 2.83 x. So the coefficient of x is just a real number, and we're fine. And hence this is why we have a polynomial, nice whole number powers on the variable, right? The degree of a polynomial would be degree 4. That's the highest whole number power. Leading term is 2x to the 4th, and the leading coefficient is 2. Alright, let's look at something else. Sometimes you might be given some expressions and immediately they may not look like polynomials. So what you'll have to do is you'll have to simplify and determine if the following are polynomials or have some polynomial form. So in the first case, if I have 5x to the 4th, 3x cubed, and 4x squared, all divided by 2x squared. Alright, if I recall that if you have, if you're dividing by a monomial, each item in the numerator will be divided. Right? And then we can just use our indices or rules of exponents to find out what do we end up with. All right, so we end up with a coefficient of 5/2 x squared. Recall, what am I doing? I am using the forms a of m over a of n. It's the difference, and if I need to, this would also be a to the 0 would be 1. Alright, so continuing, the coefficient that I have, numerical coefficient, is 3/2. The variable is x to the 1st power. The next term, 4 divided by 2 is 2. X squared divided by itself is 1, so I simply have this. It is in the form of a polynomial, right? So we have, this is in the form of a polynomial. There will be some other things as we go on. So for example, we'll learn later that we'll recall that since in a fraction we can't have denominators equal to 0. There'll be a slight restriction here in that the x's can't take on the value of 0. But never mind, the format is a polynomial. Let's look at another one. So if I have number 2 and we are given, say, x squared plus 2x minus 8 all over x. Right, so I didn't make them very hard this time. Alright, x squared over x. Each term is going to be divided by what's in the denominator. That's simple or single monomial. We simplify at each step, and we now have x plus 2 but minus 8 over x. The fact that we're dividing, or we're left with something over x, this will make it, this is not a polynomial. So the result is not a polynomial. So even though we had a polynomial being divided by a monomial, we did not end up with a polynomial. Sorry about spelling there. Right. Okay, so always check if I have something left, the variable left in the denominator, it will not be a polynomial. Or if I have a square root and the variable is underneath the square root or root, it more than, it won't be this polynomial form. Alright, so far we've been looking, if we go back, we've been looking only at polynomials in one variable, which is what we will be looking at the majority of the times. However, we are going to be going on where we will now look at polynomials in two variables. So let's see how does the definition, if they change, any at all. Right? Alright, so if we're looking at polynomials in two variables, and let's for the time being just call these two variables x and y, they now have the form ax to the m, y to the n. And as an extension of what we just learned about, the a would be the numerical coefficient, not just of x to the m, but xm, yn, the complete package of variable. X and y are the variables, m and n are whole number powers, and this time we'll be talking about the degree of the polynomial, or the term, is going to be the sum of m plus n. But as we had done before, when we put together several terms, we will look at the highest degree that we have, and that would be the degree of the polynomial. So some of those things carry over. Let me just say a couple more things. So when we have a polynomial, when simplified, whether it's in one variable or two, there are no variables. So there are no variables in a denominator, and there are no variables on the root, under a root, square root, or radical sign. Remember, radicals are the more general name rather than just saying square root, etc. Alright, now because there are two variables, we have to also be a little bit more careful, particularly when we're arranging. But let's start off with just a few examples and look at these polynomials in two variables. Okay, so examples, sorry. Alright, so if I started out with 2x squared y minus 3xy squared, when I ask what is the degree of each term, right? So let's look at the terms. The terms are positive 2x squared y and negative 3xy squared. What is the degree of each term? Then I would have 2 plus 1, or simply 3. When I'm over here, 1 plus 2, or 3. Since both of them are degree 3, then it implies that the polynomial has degree 3. Right? Okay. Now, alright. Now, is this, if I were asking about the ordering of this polynomial, how do we order it? Is it alright to start with a positive? Should I always start with a positive? Does x squared y come before xy squared? So whenever we have two polynomials of the, or two monomials rather, of the same degree, and we want to order them, order that we will use is what we call lexicographic order, or dictionary order. What do I mean by that? So let's look at x squared y versus xy squared. If I'm looking in the dictionary, this would be xxy versus xyy. Which would I see first if I were looking up, for example, a word with this spelling? This one, xxy, this would come first in the dictionary, and so that's what I will put first, right? It's already in the correct order, so no problem there. All right, same. If I make, let's look at another one. Don't get so hooked on x and y, although that's what I started out with. So if I now look at, oops, let's change our variable just to get used to something else. Q minus 7 PQ plus 12. All right, if I ask what are the terms here, the terms were positive 5p squared q, negative 7pq, and 12. Recall that this 12 is a constant term. Right. The coefficient of 5p squared q, the coefficient of p squared q is 5. The coefficient of, so this was the numerical coefficient of p squared q. You have to say out the variable or variables that you're looking the coefficient for, right? What else did we do last time? We asked, right, so what was the degree of each term that we have? And if we ask the degree of each term, this particular one would be 2 plus 1. So again, I get 3. But over here, I get 1 plus 1, which is 2. And the constant term has degree 0. So the highest degree is 3. And this will make it the degree of the polynomial. Right, so we'll refer to this as a degree 3 polynomial in p and in variables p and q, or simply p and q. Okay, so if you want to be more precise, in variables p and q, or simply in p and q. All right, one more. If we have x squared plus 9 minus 6y plus y squared plus 2xy minus 3x. All right. Let's do a few things with this. Let's try to arrange in what we call in descending order. Oops, O-R-D-E-R. right? And if we are arranging in descending order, we need to look first of all what is the degree of each term. So I'll give you a minute to look at that. Okay, somebody is saying that degree 2, they have several terms. You had x squared, y squared, and 2xy. Degree 1, you had minus 6y minus 3x. And I guess degree 0, or the constant term, you had just positive 9. So when we have terms that have the same degree, we have to put them in lexicographic order, or this dictionary order. So as I go through, I would have x squared, xx, highest degree, I'm doing descending, so highest to lowest power. So x squared plus 2xy plus y squared, right? And then for the degree 1 term, I have both negative 3x and negative 6y. We put them in alphabetical order, so x comes before y, or lexicographic order. I'd find x in the dictionary before I find y, and this is how I would order them. The overall degree of this polynomial is just 2. Right? Okay. All right, I'll give you an exercise. I'll give you 2 exercises, and then we will complete this topic and move on. All right. Okay, in doing this exercise, because we're looking at polynomials in more than one variable, or in 2 variables at this point, it will become important for you to read carefully what you are trying to write. Am I writing it just in descending order, or are we paying attention to a particular variable and writing these terms in the descending order for that variable? So here we have this example. Arrange this expression, which is 10 plus 7x to the 4th y minus 3xy plus 4x squared y squared in A, descending order, and B, in descending order of y. Right, so let's look at how we would go about doing this. So if we start off, we could ask what is the degree of the term. So just a full term. So the degree of the term would be 0 here. This one would be 4 plus 1, or 5. Let me do it there. Right. Going on, the degree on x is 1, the degree on y is 1, so the overall degree of the term is 2. The degree on x is 2, the degree on y is 2, so overall degree is 4. So all different degrees or powers here, and so we will now write in order. So we're asked to put it in descending order, so highest order term first, and so I would write the highest order is the 5th, then 4th, then 2nd, and then 0. So my solution for part A would be 7x to the 4th y plus 4x squared y squared, the 4th power, minus 3xy plus 10. And this would be done. Right, carefully check again. You see 5th, then 4th, then 2nd, then 0 power. All right. Is it any different to say I want to write in descending order of y? Let's just look back at this again. So let's start back with the original problem, and because I don't want to erase what I've just written up there. But this time, since I am looking for descending order of a particular variable, when I'm each term that I'm looking at, term degree of y only. So if I come here, it would be 0. Next term, the power on y is 1. Power on y is 1. Power on y is 2. Alright, so these two, I'm going to have to look at it in the lexicographic order. Right, which let's just look on the side. If I'm writing x to the 4th, I would write out this versus xy. Which one would I see in my dictionary first? I would see xx before I get to xy. So this one would be the first one. Alright, so what's the solution? If I am now going to find a solution for part B, writing in descending order, I would have 4x squared y squared. Highest power of y is y squared. And the next term would be 7x to the 4th y, and then minus 3xy plus 10. Right? So notice that depending on the question given, the order, even though I'm just focusing on descending orders, the result can be different. Okay? And yes, we are looking for things in the order. I don't care that you say it is, the terms are present anyway. The question is right in the descending order. Alright? Had it been ascending, it would be the same thing, but just reversed. Okay. Alright, I'll give you another one just to try. And let's see. Alright, let's say that you are given, we're going to do three things. You're given 8xy, 2x squared, 11x squared y, 5x to the 4th. And the question is, I want to write as A in descending order, descending powers of x, and C descending powers of y. Alright, so take a few minutes and do that. For those of you who are joining us on watching the video only, then remember to pause always, try it, and then resume. Alright, so coming back, we have, let's look at the full degree. This would be 2. Right, so the degree, total degree, this was 2. In fact, I'm going to do 2, 2, 3, and 4. So giving myself room, the solution for part A would be 5x to the 4th, highest power term, 11x squared y. Dictionary order would be xx before xy, so 2x squared plus 8xy. And that's done. Alright, let's look in part B, where I want to look at the degree only of the x's. Right, so I would have 1, 2, 2, and 4. Solution in descending powers of x, starting with the highest power. Again, we start with 5x to the 4th. The next, we would again have to look in lexicographic order. xx would come before xxy, so minus 2x squared 11x squared y, and then my 8xy. All right. Let's use a different color for our degree of y. Degree y is 1 here, not present. So in fact, we would say that this term is constant in y, but that comes later. All right, 1 and sorry, the degree here is 0. So we have lots of places. Between these two, I'm going to have to look at the lexicographic order and also these two, lexicographic order. All right, so let's see if we coincide. All right, xy comes before xy, so we start with 11x squared y, 8xy, and then for our 0 powers, xx, at least it ends before I look at x to the 4th, so minus 2x squared plus 5x to the 4th. All right, so these examples show you that reading carefully and following the instruction is important, particularly if you're asked to write something in descending order. You have to read carefully, is it descending order for the terms, or is it descending in one of the particular powers of a given variable? As you can see from this example, your answers could vary. All right? Okay, so we'll continue next time with more on polynomials. Again, I think we'll just be reviewing and before we move on to new ideas.